Let's start this session on climate and debt. We have 19 minutes for 4 presentations, so that's quite heroic. We actually had negotiations with the presenters, and we settled on 13 minutes for presentations, and then also ample room for questions from the audience. So I will strictly enforce a 13-minute time limit. For different papers, but I think the common thread is that there is an impact of the climate transition on fiscal sustainability, both in emerging markets and in advanced economies. And that the first paper that we will discuss by Jorge actually focuses on a very broad group of countries, including emerging markets. So I think it's good to kick off with that paper. Let me briefly introduce myself. I'm Jesper. I'm the deputy head of the International Economics and Financial Institutions Unit in the Dutch Ministry of Finance. So we cover IMF, World Bank, but also debt issues, international climate issues. We work together with the Sovereign Debt Forum, who is co-organizing this conference. We're very glad to be moderating this panel. Without further ado, I would like to give the floor to Jorge for the
Thank you very much, Jesper. I'm Jorge Uribe from the University of Barcelona. Thanks for attending this presentation and for the invitation by the organizers. This is a very ongoing project, so it's work in progress, so any comment is welcome. It's a joint project with Jose Gomez from the City University of New York and from Oscar Valencia from the Inter-American Development Bank. It's entitled Asymmetric Sovereign Risks and Some Implications for Climate Change Preparation. Our main motivation is very natural, I would say. Climate change adaptations is going to depend on the fiscal capacity and the cost of adaptation. So countries with high fiscal capacity are going to be well positioned to embark in this adaptation, in mitigation and adaptation strategies. And the adaptations also depend on the cost of funding. So it's interesting to see how this cost of funding, and in particular the yields of the sovereign spreads, are dependent on the climate change indicators we are going to see. So in short, what we do, in case that is too long, so we can take this. We examine here how sovereign spread respond to vulnerability and readiness to climate change. So there are 2 types of indicators in the climate change literature. I'm going to explain this. And the 2 are focused on how well prepared the countries are to face this challenge and how vulnerable they are for physical conditions or for other conditions. And then we expand the previous literature that mainly focuses on macro, financial, and fiscal variables because they determine the sovereign yield spreads. And we add, and there is also literature looking at this climate change indicator. So we expand these 2 branches of the field. We do not establish any arbitrary distinction, like it's useful to understand, but not for the empirical side. Like we say, emerging economies or low-income economies or developed economies. We put all of them together and we say, okay, if there are different dynamics, they are going to be dependent on the size of the spreads. So if you have high spreads or low spreads, you are going to face different effects by these climate change indicators. This distinction is like a sort of artificial because we don't really have like a way to decide in which a group any country is. So we don't do that, but still we get these different dynamics we are going to see. We also consider other measures of the occurrence of natural disasters and try to see if this also impact the spreads, and it doesn't. So it doesn't mean that natural disasters that do not impact the sovereign risk, but perhaps the effect is intermediated by other variables. We are going to discuss about this as well. Okay, the summary of the key findings is that climate change vulnerability has a really large effect on the spread on short-term maturities and also on high-risk profile countries, meaning high quantiles of the spread distribution. So it's totally asymmetrical, the effect, and this is what we document here. As other determinants different from this of the climate change literature have more relevance for different parts of the spread as well. So there is also an asymmetry there, but I'm going to focus on the asymmetry related with climate change. Including other variables to account for natural disaster, improve the overall fit of the model, but the effect, the direct effect are very small. So in terms of the empirical strategy, I have here two parts. We first use random forest, and this is important in this kind of research from our perspective, because we have a panel of spreads. So we have countries and we have time, of course. But you also have a lot of missing values because not all countries can issue the in all maturities at all times. And we are analyzing different maturities here. And then, therefore, you have like a choice to do. You can work with a relatively balanced panel, and then you say, okay, I'm going to work only with the countries with the better quality of information. But then you end up with the countries, we are going to see that, who are developed countries, and also for longer maturities. So you may bias the results. So we try to solve this, which is very difficult to solve, by imputing the variables, the spreads, the observations that are missing. And for this, we use machine learning. We use random forest. Then when we have this balance panel, we go to the main analysis. We use a panel quantile factor model in which we can model the spread distribution, which is heterogeneous across the spread level. So it's going to be different depending if you are in the high quantile or in low quantiles of the spread. So high risk, low risk. We use different maturities because there is also a large literature saying that for different maturities, the effect of the traditional determinants are also heterogeneous. So we look at 1 year, 2 years, 5 years, and 10 years maturities for these 68 countries. Then there are some missing patterns here. Our sample goes from 2000 to 2019. The short-term maturities exhibit the most missing values. There are more missing values in the short-term maturities. And also for emerging and low-income countries, you also have more missing values. So in total, we have like 34% missing values, so we have to deal with this. This is the first part. We use like a bunch of variables here, almost 60 variables that we extract from the previous literature that they say are related with the spreads. And we use random forest to input these missing observations. Or using here you have like fiscal variables, macroeconomic variables, external sector variables, financial openness, rent as a percentage of GDP, institutional variables here. We use all of these variables to perform the imputation. And then we move to the main model, And here, instead of having the average effect on the average spread, you have the different quantiles of the spread, which can be high or low. And traditional variables also that I'm going to talk about. Our main indicator for the climate change preparation and also vulnerability is the ND gain indicator by the Notre Dame Global Adaptation Initiative. This indicator consists of two parts: vulnerability with 6 dimensions, how vulnerable a country is, and readiness with 3 dimensions, which are very correlated with the institutional framework and macroeconomic performance. So you need to control for this. In terms of the results, the first part of the result is just the imputation. What we looked here was that, okay, our imputation changes the dynamics that we can expect from the spreads. We find that this is not the case. This is the correlation before imputation, only with the subsample that is complete. And this is the correlation with the imputation. And as you can see, the correlation is preserved among the different spreads here. So we are more or less confident that this imputation doesn't change the main conclusions. And those are our main results. You have different factors here, different variables that are explaining the spread. In particular, we are interested in this here, which is the readiness indicator, readiness to climate change indicator. and vulnerability to climate change indicator. So, and we can see here, the expected sign is, of course, the more vulnerable, the higher the spreads. And also, the greater readiness, lower spread. But what is important here is this is for the 90th quantile, and this is for a very low quantile, the 10th percentile. And the effects are different in magnitude. All of the variables here are standardized to have like the mean zero and unitary variance. This is like a beta coefficient model, so you can more or less compare the magnitudes across the different specifications. And what we find here is that it's asymmetrical. This response here in the lowest quantile is smaller than the response at the highest quantile. So this is true for most of the variables, but particularly, for example, for inflation is pretty evident as well, but this is true for the climate change indicators. Also, a second fact that we can notice here is that when we focus on this, when you go to this case, these two effects more or less counterbalance. So you can say, okay, you are more vulnerable, you have higher spread. But if you are more prepared, we can action this dimension, so you are going to be like in the same position. You can counterbalance this. But this is not necessarily true for short-term maturities, the red lines here, the red bars here, and for high quantiles. So this is a second fact that is important to highlight. I'm not going to go to the details when you include the natural disasters, because I think I'm running out of time. But mainly what happens is that, especially for the longer maturities, let's say 5 years, 10 years, you get a better fit of the model. These numbers here, which are in green, is because they become significant, and these are the traditional determinants of the spreads when you include the natural disaster. If you include the natural disaster variable as a regressor here, you don't get significant results. So this makes us suspect that the effect of natural disaster is intermediated by other variables. For example, you can have a natural disaster, this impacts the macroeconomy, and the macroeconomy impacts then the spreads. But the direct effect is non-significant. It's only significant when you include it as a way to model the fixed effects of countries, because this is a panel regression. It's a quantile panel, but it's still a panel regression, so you need to incorporate fixed effect by country in this context. But you model it. You model it, and it has a mean. And if you include this in the mean, then you get a better performance of the model. And in general lines, what happens is that when you measure this natural disaster variable as economic losses, the effect is negative. So you get like a lower average of the spread in the model. And the opposite is true for when you measure these natural disasters as a person's vulnerable to the disaster. So, in conclusion, you have high quantiles, which have high spreads of the sovereign risk yields, and low quantiles. And the effects of the natural climate change indicators are very asymmetrical in the two tails of the spread distribution. But you know that different countries belong to different tails. So then in the interpretation, you can say, okay, low income and emerging market economies, which are face greater spreads, are more exposed to these effects of climate change, and also both, so to vulnerability and to readiness. And we also document all the asymmetrical responses of the traditional determinant, which is also novel to the field because you get like most of the previous literature, they use like an average regression. So you cannot see these asymmetries. And also, just to conclude, the actual occurrence of natural disaster does not impact, or at least not significantly, the spread distribution, but depending on how you measure it, you can get some effect in the level of the regression. The implications is that, of course, if you are focusing on preparedness to climate change, this is going to work for countries that face low spreads, so developed countries, but it's not going to work the same way for the rest of the countries which have the high spread tail. because first, the effect of vulnerability and readiness does not counterbalance. They are not the same magnitudes. So it's going to be necessary to make more effort in this front if you want to counterbalance the effect. And second, for instance, there is a variable here which we include, which is called economic complexity here, and it's also very significant in reducing these spreads, especially at the high quantile. This is related with export quality countries. It's a variable that somehow measures this export quality. And this could be a good idea to complement this with more like a structural transformation of countries if you want to really be prepared for climate change. Well, and this is what I have prepared. So thank you very much.
Thank you, Jorge, for a very interesting presentation on an interesting paper. I think your main result is that the sensitivity of spreads to climate change vulnerability is higher in countries that have higher spreads that are more vulnerable. My question could be that I don't fully understand how this random forest imputation works, and I would have some questions about that.
Okay.
But I think actually that it's very good that you try to have a very broad sample of countries and try to include ENDEs in your analysis, because we know that vulnerabilities are large in ENDEs, that there are high financing gaps in ENDEs. So to be honest, I don't fully understand what is exactly in the random forest, but I think at least I commend the effort to have a sample that is as broad as possible. Where I would have a question is your point on readiness and vulnerability and how that equals out. I wonder whether you can test for statistical significance of the compensating effect. And also I wonder whether your conclusions are a bit strong, because for high spread countries, it seems that for some maturities actually these effects equal out. So I think the paper could be a bit more rigorous in that aspect, especially because that's one of your main, I think, policy implications. And then two sub-questions here is one, if the implication would be that countries could invest more in preparedness or readiness, then that might have a direct effect on spreads to the budget deficit or through debt. And the second one is, what is actually in your measure of readiness or preparedness? Because if I look in the paper, you write about economic, social, and governance factors. But when you read the paper, it seems that you're also describing it in a way as it's about adaptation finance and preparing a country for climate change. And those, I think, are two distinct issues. So maybe you could elaborate a bit on that. First, take two more questions from the audience, and then I'll give you a shot at the first answers. One student. Yeah.
Again, about the random forest exercise. Some points missing, and I was wondering whether the countries that are more exposed to natural disasters represent more than the third, and whether your random forest approach takes into account, like exogenous variable, natural disasters as well, to try to make the link to this other natural disasters.
Okay. On your punchline graph that showed the impact on spreads, what were the units? There were decimal points.
No, they are standardized. So all the variables are standardized. So the only thing that I want to show
is the impact on
yeah, it is written down like spread points, but it's standardized spread point. So it's to make the comparison possible.
So can you give us any intuition of what the actual decline?
No, yeah, you need to transform it back to see how much in terms of percentage points in the spread is, because it's just standardized. Yeah, but I think that we have some part of this calculation is not I cannot attend yet, because I was like more into the comparison.
I treat these countries for a living, so it'd be very interesting to see what the actual impact is.
Yeah. That would be, yes, it's a good addition.
Maybe on the first and then
Yes, regarding the natural disaster, we didn't include the natural disaster variables in the random forest. Because we didn't include the variables that are present in the second stage of the model, because it will be kind of weird. Because we then measure how this impact the spread. So we kept all of these variables out of the sample, including natural disasters. And yes, definitely there is a bias. Precisely the most vulnerable countries are the ones with more missing values. We don't think that this solves the issue, but at least it's like a small step, because the alternative would be like drop these countries, and it's even worse. Because we were very worried about this. When we compare this with previous literature, they have like at most 40 countries. And of course, if you go to the 40 countries in our sample, we have like 50% is developed countries, like 46%. So it's almost 40 is going to be almost all of them developed. So yes, but for sure there is a problem there, but we think that it's like a smaller step. I have really bad memory.
readiness. What's in that?
Readiness, yeah, readiness. These indicators of reclamation literature, they are very like broad, because they want to make like comparisons across like 200 economies. So they take sources of information that they can gather from public sources. So here you have like three facets, like economic conditions. And in economic conditions, you have some of the typical macroeconomy or the other institutional framework. And then you also have this in governance. So because they want this to be comparable across nations. So this is what is measuring how prepared in terms of institutions and economic conditions the countries are. That's why I also control them by these variables to extract if the combination of these other sources captures something else, and it seems it does.
Further questions, Stavros?
Well, a quick thing, but if you can say something, very nice and intuitive results. It's nice you put some numbers with all the criticism. Can you say something about the cost of readiness? Because you say policy implication.
Yeah.
But if it may cost more,
So totally agree. I can't. But it should be, but not with this model. You only can say like the cost of debt. How is this going to be impact? But of course, the readiness has a cost as well. So you cannot perform like a cost benefit analysis with this. This is only like one side of the picture. Yes. And we have tested, we have tested as well for the difference in the tails, and they are statistically different, but yes, testing for the counterbalance is more difficult. I think that we don't want to set this like a main point, but because it's going to be difficult to test for this and get different results. For the tails, for sure, we have done that. Okay, thank you.
Final question? Or not, then thanks a lot.
No, thanks.
Let's turn to Stavros. There's one housekeeping question. Is Stéphane in the room? Perfect. No, we should actually keep the times. Perfect, 30 minutes, that's it.
okay, great. Okay, so my task in 13 minutes is to first convince you that we have a model that's reasonable, but more interesting is what are the results from this model. So the title of the paper used to be Best Sustainability Analysis Under Transition Risk. It was about the model. But by the time we finished, I want to turn it around and see what do we really learn about the problem that we want to study with this model. And to see how much confidence or how comfortable do we feel about the results based on is the model realistic and how much do you know about the data. The topics we're discussing here are very complex. There are many angles. And I want to make sure that at least the one angle I'm studying, the results I'm giving are people can feel comfortable. So this is joint work. Veronica is somewhere in the room. If there are any questions, we can PhD on this. It's a very demanding to do the models and do the data management correctly. And Giacomo Morelli is his care advisor. So 13 minutes, I will try to give them without equations. So this is what the model has, the paper has. So what we did, we started with a stochastic debt sustainability analysis model, which we have developed a while back working with the European Stability Mechanism. A unique feature of this model is that it's stochastic on a scenario tree that we can calibrate the key economic, financial, and fiscal variables. And being a scenario tree with long horizons, we realized that we could modify it based on any new information we get about climate. And actually, the first paper we wrote on this, we just took the ND not dumb data, and we put them in just to show how this works. Now, we take this model and we step back. One of the input to the stochastic DSA is interest rates. What is the cost of debt finance? But the cost of debt financing depends, and we'll show it, on the energy transition. So we go a step back and we look at the climate policy relevant sectors. This is work coming out from Barcelona and Monastirolo, who have been studying this issue for a few years, very carefully calibrated, showing how the climate policy relevant sectors, if you shock them, they change the probabilities of default of a country, which means it changes the cost of debt finance. And you go a step back from this Barcelona-Monastirolo model to integrate assessment models from the network of the greening of the financial system that provides under different transition scenarios, orderly or disorderly, how the energy mix is going to shift. So we take the energy shift under different scenarios from NGFS phase 4. We look at the country's current energy mix and energy intensity, apply the Barcelona-Monastirolo methodology to estimate changes in probabilities of default. We calibrate the spread, the beta. How does the spread respond to changes in probabilities of default? And this becomes the input to our stochastic DSA. We don't look at the growth effects. Caterina gave a very nice talk this morning about growth effects. And there is a debate there. Should we do both of them? Is one of them enough? At least we're doing different part of the problem. What I like about her work is different from ours. And what I like about ours is different from hers. The part we're dealing with is carefully done. Now, in our model, if someone says, can you do growth effects? The answer is yes. I just want someone to take responsibility to tell me here are realistic estimates of growth effects under transition that can put them in. Can we put in a fiscal cost for adaptation? The answer is yes. Assuming someone takes responsibility and say here is a reasonable estimate. So for us, it's not just to doing mathematical exercise. So NGFS took responsibility to say here are possible transitions. So believe my results to the extent you believe in it. Some other inputs we put in, if you look at the 50-year horizon to cover the transition until 2050 and then see what happens after that. We take projections from the IMF WEO until 28. And then after that, we assume long-term average projections. For the case of Eurozone countries, we look at the European Commission aging report that actually has projections until 2027. So someone takes responsibility for the input data we put in the model. And I take responsibility that the model is realistic. Yield curves. What is the long-term natural rate of interest under climate transition? Well, some very credible people write papers arguing it's going to go down
and dark green is going to go up. I'm fine with this. Okay, it's a difficult problem. What we did, we take kind of a medium rates, like 2.5% is the long-term average, not the natural rate, the interest rate on the risk-free on the US market. And we did a test assuming very low rates near the zero lower bound, like 1% of the limit. And again, once the Bank of England or Professor Ferry figured out it's going up, it's going down, it's okay. The country's debt, existing debt, fits in, and the result is stochastic debt sustainability, is the debt stock dynamics, how the debt stock dynamics evolve over a long horizon. And this is what you are going to see. The blue line is without transition risk, and the red line is with transition risk. We will see in the careful testing that the effects start being noticeable from around 2030. So it's not a very long horizon. We will also see that almost all countries are affected adversely, maybe except Finland, are affected adversely. And you will see that the trends are upward sloping. Now, this presumably means it's not sustainable. Now, if you take Finland right now, very low debt rates, today Finland has a trajectory like this. Nobody thinks Finnish debt is not sustainable. The question is, can they adapt? Can they change their historical primary balance so they can bring it down, make reasonable adjustments? Greece could not. Greece suffered to make adjustments down. Finland can. But you also ask another question. How much green growth do we expect from the transition that will offset this problem? So here are the two answers we're giving. We document the shift upwards, if you believe NGFS and if you believe these projections. And we say, how do you bring it down? Either by extra fiscal effort, how much do you need? Is it realistic to expect it? Or by green growth. Do nothing and green growth will solve your problem. And once you see the numbers, then you make up your mind. This is feasible or not. Okay, and you have benchmarks for these numbers. So this is the point. Okay. So this is our debt increases under transition by 2070. We did like US, Australia, UK, and India, and 9 Eurozone countries. We plan to do a few more, but we're not going to do models on Veronica reaching her limits of running the models. But here's an important point. All countries now have very high debts. And when you do DSA without transition, you find out that they're in trouble. If they keep spending like they're spending, things are moving up. There is an IMF Article 4 report about the US. It says they need adjustment, 3.6% of GDP to stabilize their long-term debt. So the first thing we did, say, if we want to study transition risk, let us take the current debts and stabilize. Try to adjust so you stabilize. And then you compare countries' effect of transition risk, assuming their current debt problem has been solved, has been stabilized. What you see here is that debt increases in percentage points by the end of the horizon under transition risk. Like US and Italy have a big shock, about 50 percentage points, all other countries 15, 20. But if we do the same exercise without stabilizing the current debts, so realizing that you have no big debts and transition risk on top, many countries are over 50%. And the slope is up, is pointing up. So what I'm going to do is ask the question, how much green growth do you need to solve this problem here? Or how much fiscal adjustment do you need to solve? That's in 2 minutes. Okay. Okay, so our model, one feature of the model, it is doing optimal debt financing. This is the amount you issue at time period T of maturity J. We go up to 30 years that a country can finance debt. And the country has to select the optimal debt financing. Stock and flow equations are fairly standard. We set it up, as I said, on a scenario tree over long horizons. So we look at the stochastic interest rates, primary balance, growth. But this scenario, we modify what they call in the climate literature narrative scenarios, like different RCPs or different SSPs, or in our case, orderly versus disorderly. So we fix a scenario and we choose a climate model. And we use the models from NGFS. So let me skip. So the model is optimize the cost of debt financing subject to a flow constraint that the flow has to stay below 20% of GDP. 20% is a number coming out from IMF for developed economies. And the debt stock dynamics are not increasing over time. These are the sustainability conditions. We find that for all the countries we analyze, this 20% flow variable can be satisfied. So there are no immediate flow concerns, but the long-term debt dynamics are going up. Okay, so I'm not going to tell you anything more about the calibration in the model. Some of the tests we did. First, compare with IMF Article 4. The red triangles are from the IMF Article 4. The charts are the charts are our model. So I think you can have confidence that our model is doing something reasonable. The trade-off, cost versus finance risk without climate transition, under orderly transition, under disorderly transition. Non-trivial shift. So it does have an effect. Orderly seems to be worse off, but in reality, if you look at the data, not that much. So one of the conclusions is orderly versus disorderly transition is not a question to be solved based on debt criteria. It makes no big difference. For reasons I can explain in the Q&A. These are the debt dynamics. This is the US under orderly disorderly. This is Italy shifting up. This is the extra effort. How much extra effort do the countries need to do to stabilize their transition risk? Do they have to go to a surplus or can they keep running deficits? US has to adapt a lot. The red bar is the range of estimates for different climate models. So all the countries have to make a positive adjustment, except Germany that can spend more and still meet their targets.
At -1 minute.
Minus 1 minute. This is the Porter hypothesis. If there is no green growth, things go like this. If there is green growth, things can stabilize. And the question is how much green growth? And that's my last slide. Different countries, depending if you look at interest rates, high or low, and orderly, disorderly transition, on the average, green growth between 0.4 and 0.7% average across countries solves the problem. So the problem is solvable, but if you look at individual countries, it differs quite a lot. So significant transition effects starting from mid-2030s. They have an effect on how you do the debt financing because the frontiers are shifting. The transition is manageable if current debts are stabilized. So that's a big condition. Orderly versus disorderly is not a debt sustainability question. Differences across IAMs is not that big, as you have seen, we're very close. But interest rate uncertainty is a major issue. So my bottom line is, do you bet on low interest rates to solve the debt problem under climate transition, or do you bet on the Porter hypothesis? Green growth will solve it. I'm -2.
Thank you. My main question about the paper you actually answered already. It's you focus on this beta, which I think is the key coefficient in your model, the impact of the green transition on default probabilities and how that affects interest rates. But what about growth? What about deficits? Well, and then your answer is actually, well, Veronica will have to model it, and that is quite a task. So let's keep that out of the equation now. But then your conclusion is, well, the main thing we need to worry about for your final bullet is interest rate uncertainty. To what extent is that a feature of the fact that you focus only on the interest rate channel? And secondly, you are not fully consistent because you say, well, we don't look at growth. And then as an afterthought, you said, well, we might actually hope for the Porter hypothesis. So we might actually hope that the green transition will deliver higher growth. So wouldn't you want to be more symmetric there? And in the afterthought of your paper also present a case where we don't have a Porter hypothesis, but where we have a scenario where actually growth will disappoint due through the effects of the climate transition. Because as a policymaker, what I read in your paper as well, we can actually hope for the best, low rates than the Porter hypothesis, and we don't need to do adjustment. So that would be my question. Maybe two other questions from the audience. Stéphane?
Yeah, about the NGFS scenario. NGFS scenario transition policies through carbon price and modeled macroeconomic model as carbon tax. And according to orderly disorderly, it's distributed, the proceeds of the carbon tax is distributed differently, so either to households, to government investment, or to pay back debts. I guess that this play a role on the growth profile of the DSA, but also on the government's revenues or expenses. So I was wondering whether you take this into account.
One more, or should
So, what is the role of uncertainty around the growth rate? So, does it higher regarding the transition scenario?
So let me take them one at a time. Maybe I should have taken repeat it quickly because
How you treat Cyprus, the tax
yes,
proceeds?
the proceeds. Okay, we do not model the cost of transition under the assumption that the government, like 3.5% of global GDP has to be spent on transition. Who's going to pay for it? And a rough estimate is the governments have to pay 1/3, like 1%. We choose not to put it in under the assumption that the government is going to get this money from the green taxes. So there is no extra burden on the country, on the government, to spend on transition. But for us, it's easy to put it in, again, under someone taking responsibility. If the IMF concluded that the countries, give every country projection, how much they have to spend on transition, I can put it in. And now we operate under the assumption that the country will get carbon taxes to invest back in the transition. On the growth, we are not inconsistent in the sense that we think that interest rate, prices, everything that's going on, right? So, so in this sense, if I say interest price, everything on, I say, well, Caterina, you shouldn't do what you do, right, with the growth. But I think it's correct to do because we are not sure if the market now price correctly the climate. There's lots of literature saying that it's underpriced, and we are in for appropriate price. So when someone focuses on growth as an important channel, it's worth studying. Some of us on interest rate saying, I assume, based on some literature that shows very small growth effect, is worth studying. My results will look worse if we talk some more with Caterina and take her growth effects and put them in. We'll just show things look worse, which means you need more green growth. So we can answer these questions if we have the data and the uncertainty. We model on the scenario 3. Let me step back. I try to keep separate two forms of uncertainty in my model. The traditional statistical uncertainty and ambiguity. So we model on the scenario 3. We model uncertainty about growth based on historical data. Look at the volatilities, look at the correlations, and we build our tree. Now, if there is a shock, like the ones you are studying, for me becomes another tree. It shifts. Now, if you have estimates, or someone has estimated that the growth of a country, instead of being the long-term historical average I use, with the historical volatility around it. If someone tells me that under the climate transition, this growth will shift and volatilities will shift, I can put them in. But since I don't have much confidence in this result, this data, I say I'm going to do narrative scenarios. Okay.
We have one final question.
So regarding the interest rates, you do not compare so you do not take the NGFS simulation of the interest rate. You just
Correct. No, we don't. For interest rates, we take the standard DSA, like the interest rate of different maturities is the risk-free rate of the country, plus a term premium, plus a risk premium that's a function of debt. That's how we do it with ESN. And to this risk premium, we add the shocks from changes in the probabilities under a narrative scenario S, under a model. So this is about the Stone Monastirol estimate. Okay? So the underlying interest rate is the current yield curve.
But what about the risk-free interest rate?
The risk-free interest rate is the current yield curve. Or actually not the current, because now rates are very high because of inflation. We took yield curves that had about 2.5 average long term. Okay? And then for this low rate sensitivity analysis, we said, let's look at rates that were 0 and going to 1%.
So we can move to the next.
How long is that?
Probably the lunch interview. Thank you, Stavros. So let's turn to Caterina.
Also put the timer.
Very good.
Good check.
Well, it didn't work with Stavros, so much for AI taking over jobs.
It would have worked without it.
You
don't have to
Perfectionism. Yeah, that's true.
So I'll change the style of my presentation from what you've seen so far. I am a practitioner, and so the way I present and how I will discuss will probably be different from what you've been hearing for the last couple of days, today and yesterday. Can I get a show of hands how many practitioners are in the room? Okay, so we have a handful. Where do I go? This, is it the right button? Right button. Okay. Maybe go this way.
Is it because it's PDF?
Oh,
Maybe.
I think it's no, it is not a video. Yeah,
It's not.
it's a PowerPoint. I'll just you can just look at So what I'm going to talk about is for the last 5 years. Oh, and so I'm at the fund, but I came to the fund a year ago or so. After being a practitioner for a couple of decades in the investment management industry and finance industry, and my interest in sustainability, and that's sustainability not from a sovereign debt sustainability, but incorporation sustainability from investment perspective. And in the last 5 years, there has been a huge shift in how institutional investors incorporate sustainability when they are making investment decisions in sovereign debt. And as you know, sovereign debt is the largest asset class, it's the most liquid asset class, and it's a significant component of all institutional portfolios. And the sovereign ESG has been very slow to arrive. It probably arrived at the start of the pandemic, literally, when pretty much every asset manager started to release their own sovereign ESG approach to how they treat purchases and investment strategy in sovereign debt. Before I get into the findings of our study that basically evaluates how the sovereign ESG sector has evolved over the 5 years, the first study we did was in 2020. We took a first step of the emergence of very nascent sector in sovereign ESG, and we just published a couple of weeks ago the updated version to see what progress has happened. I want to put this this diagram, sort of a value chain in purchase of a sovereign debt, and that is influencing how now sovereigns are thinking of issuance, and you would see quite a bit of emergence of the new instrument, a thematic instrument, whether it's green bonds, sustainability bonds, or new sustainability-linked bonds, and between the end investors. And in our studies, we have a series of publications. We look at how ESG utility functions and new ESG preferences and methodologies are affecting all the different parts of the value chain. And they're quite different in terms of what they do. And what I'm going to be focusing on today is the ESG providers. And also before getting into the study, and by the way, I will not show any formulas or get into how we did the analysis. What I do is I will present our summary diagrams and our interpretation, and that we find very useful when we engage with the industry in how then they incorporate that into decision making. Oh yes, and maybe one comment to say that this study is based on a lot of discussions across the industry with credit rating agencies, with investors, with all ESG providers who were part of the study. So conceptual underpinning of why sustainability, sovereign sustainability within sovereign debt is such a hard issue. And you did a lot of methodology, credit rating assessment methodologies. You talk to credit rating agencies. It's probably just 3 to 5 years at most, but it's usually on the low end. And a lot of the macroeconomic and fiscal variables do fall under that. And so it's easy for them to take into account in all the methodologies. Even if they claim that they incorporate ESG factors into their assessments and credit risk, the reality is those factors are much more long-term, they're non-linear, and it becomes analytically and methodologically very difficult to incorporate that. So there is a lot of complexity in this. Yet, when we talk to practitioners, they already need to make the decision. So there is only so many issuers. They can't really afford to exclude sovereign debt from their portfolios because then it would reduce diversification. So they need to have heuristics and the ways to make the decision and make assessment on the sustainability or sovereign sustainability of an issuer so that they can bring this into consideration. So let me then first summarize the key findings, just to select one so that we can focus on it. And then after that, I will support them with the tables and charts of how we came to those conclusions. So sovereign ESG providers is now a multi-billion-dollar industry. So what you will see if you are an investor or an asset manager, you now have, it became a part of the investment process to procure the data on the ESG. And in our survey with investors, they usually have multiples of those providers in it for a variety of reasons. And there has been in this industry sort of a normal common knowledge of aggregate confusion. Those of you who've known that was sort of how ESG providers is seen, because different providers would have very different assessment in the corporate space of a corporate issuers. Right, but then that became what we started to find out, that this aggregate confusion started to be interpolated into the decisions on sovereign debt, which is wrong. So what we found in our studies and what we called it collective conformity, and I'll get to this, is that in fact, all the sovereign ESG methodologies are aligned. They're 90% correlated. I'll get to this. So it's the, and we really urge very different treatment of sovereign bonds from ESG perspective, from corporate bonds, and whatever the studies you see on a corporate ESG should not apply, but they do seem to be adopted for sovereign debt as well. Environment and climate, since our original study in 2020, has become a much more growing focus, but it has actually taken a few steps back in terms of methodological incorporation. We can get, oh, that's something is. So what happens? So we have basically all sovereign ESG providers provided us data. Usually this has been, they provided it for academic research. Otherwise, it's quite a costly undertaking. And what you will experience is when you're talking to all of these different providers, they would be telling you how unique they are, how they really understand the sector, how they're able to incorporate sustainability. And this diagram is basically, we summarize, take the different indicators and put them into E, G, and S columns, and you will see just by this color scheme that you would get the impression they're all very different. And that's what they would want you to believe, that they have taken a very tailored look into the sovereign debt. But what comes out at the end? They're 90% correlated. I think what, and we've now seen, we have several publications on this, getting into understanding. And I think Stavros said early on, it's very important to scrutinizing what are you told in terms of what kind of data sources you get and what the conclusions you get in. I have big views on ND gain. I'll get to it for the same reasons, because ND gain falls into this. ND gain is 90% correlated with GDP. And when we looked at 10%, the rest is noise. So what you see is that they basically, you could have used the proxy as GDP as the proxy, and you would have just received the same results. So the problem with the sovereign ESG is that regardless of what they tell you or what they produce in the documents, they are 90% related. We call this in our original study ingrained income bias, is because it is basically income, national income, GDP. We've done different tests on what's the residual. Residual is pure noise. But what happened in environmental score, there is significant dispersion in what they do. So in our original study in 2020, the correlation I think was 0.47. This one I think is 0.2 on the aggregate. You will see in the picture in maybe we can, oh yeah, so this one is from our original study, this one from here. So it's still very highly correlated across all of the providers. Environmental went down. So there is, and you would think maybe they are now taking very diverse view on what environment and climate is. I'll just skip few to, and this is basically the ingrained income bias, where you would see the income of the countries, rich, middle income, low, and the correlation. And what's the happening with the environmental pillar? Environmental pillar has troubled us, actually, as we were trying to understand this. And you would, it was very difficult to understand the methodological underpinnings. I think one of the key challenges in environment, in particular, environment and climate, is the existence of the data. And by the way, this covers 180, 190 countries. So it covers the full spectrum, right? So they, I want to give a huge credit to sovereign ESG providers, is they do produce data and use AI and use some other methods to get the different inputs into the assessments across the full spectrum of the countries, including low-income countries as well. And that's probably what makes their job a bit more difficult. But then approach to how they think about environment often constrained by what data is available. And in our original study, environmental data, high quality environmental data that is available is usually lagged by 3 or 4 years. So when they need to make the decision now, what they have available in all of the best data sets is actually 2019 and would be the most available data possible. So they need to have some heuristics and some other ways of filling in the gaps. And
You have 2 minutes.
so I'll leave this at that. I think what we found the maybe overly mechanical, overly reliant on data mining approach to solve this issue, and it's taken us in the wrong direction. I think this is we're engaging with the industry and with the providers of this, but this is really, really something that needs to be looked really carefully at. And so we got quite an interesting response from the industry on this. I'll leave it at that, yeah.
Thank you. The question I would have is that you write in the underlying paper that ESG scores are functioning quite well to help investors identify how ESG proof their portfolio is, but that they don't incentivize governments to reduce emissions on the E pillar. What do you have insights on what would be needed in order to get there, or is the signal just too weak, or is the impact too weak? And that I thought might also be a way to, because it is problematic that for EMDEs, there's a high correlation with GDP levels. But if there's sort of a link between policy measures that you take and the delta in your ESG score, then still there might be a value in ESG scores in incentivizing good policies.
I would question your premise that sovereign investors have an influence over governments on reduce emissions. I think that process is much bigger than any institutional investors can do. However, what it does do is, and by the way, this is all of the different papers where we looked at different aspects of that value chain for sovereign debt investment. What it does do, and we've seen shift significantly, the ESG scores and what goes into them are influencing sovereign response to them. So just to give you an example, we were on an anecdote, we were on a call with one of the sovereign ESG provider, and one of the senior participants had to be called out of the call because the prime minister of one country called the company because they got downgraded on the ESG, and he was worried because he was about to issue a debt. And so that basically, we had a follow-up conversation with that, and the Prime Minister's office was having very active dialogue with the ESG providers. So there is an influence, and now through the work of World Bank colleagues and IMF colleagues with their management offices, they are paying a very close attention as to what sovereign ESG providers are doing, so that there is a much more active dialogue into communicating what are the policies are and what are they doing. Because one of the things we know investors want to have reflected in their portfolio, not even so much ESG indicators, but ability to understand the policy making and ability of countries to execute on the policy. So, for example, if they have NTC goals or if they have certain targets, whether they would be in a position to actually execute those policies. They want to take that into the investment decision, and that's right now not incorporated into the methodologies, but there is a lot of work is trying to proxy that type of information.
Let's take 3 questions from the audience. Stavros?
I'm tired I was taking a picture, not of you, but on some of the slide.
Oh, why not?
Outside the GPRD. And you said that the correlations are declining from 0.42 to 0.27.
Yes.
But then your main message is they are not different. They
on E. So can we go back to the chart with the tables? This one. So these are the all aggregate scores. Okay. So that takes into account basically everything and how they aggregate it. So when investors make the decision on the sovereign debt, they use those numbers, aggregate.
So the bottom line from your point of view is makes no difference.
Makes no difference. So when investors on this unless that changes, and we've identified that even in our paper 2020, and we know some of the investors are not investors, ESG providers have started to make some income adjustments, etc. We've analyzed that, and I don't get into this, but we did reflect this in the paper of the effect of that. There is 2 out of 6 have gotten into that marginal effect, but the other ones basically went on defense and they say, well, this makes sense to us because we have risk-based provider and risk increases with as the income decreases, something like that. So there is a little bit more that goes on through that. Mm-hmm.
You mentioned that there is this correlation between the ESG scores, but is there also correlation between ESG scores and non-ESG? And if it does, what is the additional value? If you are investors, if there is a correlation between the ESG score and normal,
credit rating?
Yes.
Yes, we have a paper on credit ratings. In fact, but because, and you can infer from here, because credit ratings are highly correlated with country income. So then ESG is also highly correlated. So they're highly correlated among themselves. So then as you conclude, there is very little value add from this, which is not what happened why ESG emerged, because when they started to emerge at the sovereign level, it was because of dissatisfaction of what credit rating agencies were producing, and institutional investors wanted to get more sort of non-financial, non-economic factors into their decision. And the ESG providers started to produce that methodology with the expectation that they will complement what credit agencies do. And this is our studies, we basically revealed there is really no additive value to that. So we think there is huge value of having sort of alternative approach in the industry, but let's have that conversation that they really have to be complementary. We not want them to go away. No, we want them to basically take this a little bit deeper so that it's genuine sustainability. Mm-hmm.
Final question.
Hi, thanks for the wonderful presentation. Paul Delaguardia. I used to work on a lot of these topics at the Institute of International Finance, the intersection of sovereign debt and sustainable finance. So you just answered one of the questions that I had, which is, wouldn't you expect to see some correlation? Because some of the research that I had done in the past found that a lot of the scores, ESG scores in the corporate space as well, were kind of all over the place. We haven't really had time to get into the sovereign ESG scoring lines there, but yeah, we found like if these scores are all over the place, what do they really mean if they're claiming to measure from the same things? But I guess it's the opposite situation if they're supposed to be complementary. But also, I just want to point out that, from a practitioner perspective, there was a constant misconception that we kept running into around ESG scoring in general, that often observers would think that it was about the issuer's impact on ESG factors, whereas in fact, it's generally talking about the impact of ESG factors on the issuer. And it's just a perennial issue that we were trying to overcome. And finally, just getting to my new question on the income bias, which is, as far as I understand, talking about how the higher scores correlate to higher GDP per capita, for example. You think about an overarching issue where, for example, if you're measuring the wrong thing, territorial emissions as opposed to consumed emissions, you could actually assign a great score to a country that has a lot of territorial emissions, but actually all those things are exported from another country that consumes those emissions. So with those types of ideas in mind, do you see that sovereign ESG scoring actually helps direct capital flows to sovereign issues that are quote unquote good and that really need done, that's low income countries or others?
Can you give a brief answer?
Brief answer. And this is in our original paper. We find that ESG scoring as it is now diverts capital away from towards more rich countries. And in fact, JP Morgan ESG index, for example, which is the only ESG index for emerging market debt, you could see how it overweights. We have the data in our original Demystifying ESG paper. It's one of the links in there. It's basically you divert capital away from where it should go. And that's troubling. So one of the, why are we doing this? Is because of that. It's because it's misdirect the capital, and that's the most worrisome from our perspective. That's the bottom line.
Okay, thank you.
Mm-hmm.
Thank you.
Mm-hmm.
Let's turn to Stéphane for the final presentation.
Thank you very much for the invitation. Presentation is about it's about the green transition and public finances. It's a joint work with Caterina. So all difficult questions we will do, of course. So let's keep this. So the research question is quite simple. We have urgency to act upon climate change, and we need additional mitigation effort. Governments are the forefront of this action, and there are several policy options to take this into account. First, we can take this as two polar cases. On one hand, you have carbon pricing. You charge private agents in proportion to their level of pollution. And the other polar case is you take through public money part of the mitigation through public investment or through subsidies, but you put public money into the mitigation effort. From a public finance point of view, it has completely different implications. If you take carbon pricing, you get revenues, so it's good for public finance. If you go on the other way around, public investment or subsidies, it's not good for public finance, it's a cost. So what we do is we try to model this trade-off, I would say, through a dynamic general equilibrium model, and we try to analyze with this model the macroeconomic implication of the transition and its consequences for public finance. Yes, it is. Policy issues, simple also. usually, and Stavros said, additional investment represent between 2 and 4% of GDP every year at world level. For countries in Europe, the Commission said it's close to 4%. And we have also estimates of the share of public investment or public involvement in this mitigation effort. It goes from 28% to 50% in the Asymmetric Matthews report. What we argue is that the sustainability of public debt should act as a ceiling on the share of public investments. And we have, for instance, in the IMF Public Monitor, this strong conclusion that if the transition were to be mainly financed by public support, debt would become unsustainable. Literature is very scarce, actually. On the policy debate, it starts to be discussed by the ECB, by the IMF, but on the academic world, it's not very much covered. We find, again, a Stavros contribution and Battiston Monasterol. But beyond that, it's not very much integrated into the academic debate. What we do here is we bring together two literature streams. This macro model with environmental components return on chemical and video. And on top of that, we add this public debt sustainability considerations that we borrow from models are Corsetti and Porthos. The main results, let's skip this because we go to the main results soon. We don't have a lot of time. Brief representation of the model. So it's quite a simple model. We have three agents. So we have firms, they produce, but when they produce, they also emit CO2 or greenhouse gas emission. Households, they consume, they provide labor and invest in capital of the firm. They also hold government bonds and pay taxes. And the third agent is the government. Government is subject to a carbon budget. And so to act upon this limitation, they have several policy options in green, either carbon taxes or subsidies and public mitigation. On top of that, they act as a regular government, they have taxes, and they have government expenditures. What we have in this model is that government can't default. So if there is default, there is a partial transfer to households of what remains after default. What matters here is not the default, it's the probability of having a default. Of course, everything together leads to government debt, and according to the level of government debt, you have an impact on this probability of default. Just few elements of the model without taking too much time. So again, we have this carbon budget, which is given by the Paris Agreement and the IPCC indicators. What is important here is that emissions are a byproduct of GDP. So key is emission, why is GDP, and you can reduce these emissions by this mitigation effort. And you have two types of mitigation effort, the private one and the public one, NG. Firms maximize profits, and in the maximization of profits, so you have output, wages, cost of capital, but you have also mitigation costs. Is A, and A can be reduced by the level of subsidies that the government can bring, and you have taxes that has been paid on the level of production. Government also consume, works, invest, pays taxes, and invest in risky government bonds, and because you have this risk of default, there is a wedge between the risk-free rate and the rate that the government pays on debt. This probability of default depends on the level of government and the discrepancy you have between the actual level and the debt limit that Caterina talked about earlier this morning. So probability of default increases when the debt is closer to the limit. What is very important also in the model is this abatement cost. Abatement cost depends on this mitigation. And you have two types of abatement costs. One is related to private here, and one is related to public, AG. And you have two important parameters, which is the degree of convexity. And we assume that this theta 4 is lower than theta 2, so for public compared to private, which represent the fact that the public sector is acting in the mitigation effort in sectors that are very difficult to abate, or most costly. I will show this later in the results. Calibration is quite standard for the macro model. For the transition part, again, one important thing is this abatement cost relatively higher for the public than for the private sector. And in fact, if we look at the curve, the marginal costs are lower for the private at the beginning of the transition, and they are increasing above the public marginal cost as we approach full transition. And all these things then come from our imagination. We take this from some actual computation, especially in France. We have people working on that at the sectoral level, notably Patrick Picky. 5 minutes. It's good. And we have also, again, this in the Pisani Ferry Masso's report. So 5 minutes to get to go through the results. We have three main scenarios, two extreme, only carbon tax or direct public investment, and a carbon tax with subsidies. Benchmark results for France, but we do some sensitivity analysis with two additional countries, a high debt country, Italy, and a low debt country, Germany. And I'll come to the numbers afterwards. So just, there are many charts and many lines, but just this illustrates the main trade-off. What is the main trade-off? Is that if you go through carbon tax, it's good for public finances, so you have a decline in debt to GDP, but it's not good for economic activity. So there is an economic cost, GDP declines, consumption declines. On the other side, if you go through public investment, it's good for economic activity. You have some demand shock that is supporting activity, and the impact on households is more limited. But it's bad for public debt. You have an increase in public debt. At the end, it stabilizes because we have public stabilization rule. But during the transition, you have some increase in public debt, and because it increases the probability of default, you have also an increase in the interest rates, sovereign interest rate. If you take into account the starting point of the public debt, it matters. So if we compare, for instance, France, which is the case I showed before, with Italy and Germany, we have a different picture. Just one very important one is the impact on interest rates. For Germany, you see, if you go public investment, it doesn't matter. It doesn't bring additional pressure on public debt. But if you do it in Italy, you are. So starting point for level of indebtedness matters. What we do next, we assume that this increase in the sovereign interest rates could have some spillovers on the private cost of financing. So we use the literature, and when you have an increase in government interest rates, it increases the private capital range. What it implies, so here it's on Italy because it's the high debt country, but you see that when you take into account the spillover effects, which is the dotted line, this positive impact we had before on GDP disappears. Because the increase in the private cost of financing that you see here brings down private investment, and this has some negative impact on GDP, even you don't have the trade-off anymore. As negative as if you go through carbon tax. So this trade-off disappears. It's when you account for spillovers, public investment not only deteriorates public finances, but has negative impact on activity. Last thing, we do some welfare maximization to compute what would be the share of public involvement in the mitigation,
public versus private. And what we obtain is this line here. So this optimal share of public involvement, we start from 0, and then we gradually increase up to 40%. What does it mean? It means that at the beginning of the transition, we need a sharp increase in carbon tax because it's not very costly for the private sector to decarbonize. So the private sector is the first to enter the mitigation effort with a very high carbon tax. And then when the mitigation effort starts being more costly, then the public sector enters gradually into the game up to 40% involvement. This allows to have a stabilization of the debt level, so even a decline at the beginning because of the carbon tax proceeds, and then stabilization afterwards, and the impact on GDP is more limited than when you go only with carbon tax, and it's more temporary. I think I'm done, or just some concluding remarks. So main finding, transition policies are preferred for low carbon future. Those increasing public debt present significant challenges, potentially making the debts unsustainable and leading to higher financing costs, thus hindering the transition. So what we think is that when you take especially into account these spillover effects, you have this further degradation of the macroeconomic impact of public finance implication. And lastly, this pivotal role of initial debt conditions that, relative to what Stavros said before, taking into account the current debt issues is very important for active in the transition phase.
Thank you. Would you like to follow up on your final bullet? Say that countries with more fiscal vulnerabilities can be affected more negatively by transition policies. If you look at your policies, you see that your high debt country actually has the highest share of public investment versus private, the lowest carbon taxation, and still manages to stabilize its debt. Can you tell a bit more about what's going on there in the engine of your model? Yeah, so Italy is the dotted, right? The stripes, which has the highest share of public, yes, the lowest carbon tax, and still that will stabilize, while your final bullet says, well, risks are higher.
Yeah. So in fact, this computation depends on many parameters in the model, especially the energy intensity or the energy mix in the country. And depends on what difficult questions.
So your question is what determines the share of the public investment?
Why the high debt country is
why the high debt country has the highest optimal share of public investment. But you would expect maybe if you're highly indebted, you can't afford.
To GDP, but also other parameters. For example, the elasticity, carbon intensity of GDP. For example, is higher for Italy than for France, and also so this is in Germany and then France. So it also depends on the because Germany and it also depends on the TFPS. I think there's something related to that.
The share of public consumption.
Exactly, and also of course on the share of public or of public expenditure. So it is determined by the three things. And actually, this share of public or total payment also is quite sensitive also to the to the public expenditure, which doesn't relate to it. So if you change that, in principle, you could increase, if you do decrease that, you could increase a lot.
Since you compare three animals and different controls and organization, that makes sense.
Yeah, in France, this part of public consumption around GDP is quite high, so this limits also share of public involvement.
And I think the other question was why you were able to stabilize debt. So basically, we assumed we have an assumption that we go back to the original debt to GDP level, and we will have that long-term tax actually.
So that's why in all simulations, go back here for debt stabilization. What matters for us is during the transition, you can have this sovereign risk considerations.
There's a debt stabilization.
So we go to the audience, questions? I was asking you already, is there someone else? If not, then Stavros, go ahead. Yeah.
So I think, Stéphane, it's a question, but also a comment. How much faith do you have in the conclusions? And this has nothing to do with the quality of the model. It has to do with also what Caterina is saying. Well, there are many parameters, which is the same thing I'm saying. So how do you compare? I mean, I'm kind of happy that I see that other people say that, look, we are in trouble when it comes to debt. Because I was telling Veronica, well, I'm going to get up and say that we're bankrupt. This seems to be the conclusion from our studies. But it's a conclusion under lots of caveats. So how do you communicate this information? That what are the parameters in your model or my model or any model that you tell your minister or you tell the G7 who are in trouble? Or under what parameters you tell the G7, it's a difficult problem, but it's manageable. From a policy point of view, I think there is this tendency to think that we are facing a lot of shocks. Every time we have a shock for Ukraine, we get, I don't know, 10 points of debt to GDP or higher. So the issue is said, yeah, if we are closer to a certain limit, we are reducing the fiscal space, and then we have less space to tackle the transition issue. So that's, I think, the main policy message is that if you want to have a good public involvement in the transition, you need also to have fiscal space, and take into account also this complex sustainability considerations beyond the transition. So you need to have sustainable debt, sustainable public finances, if you want to have a real impact as a government with public money in the transition. Then, of course, the model is quite simple. There is a simple agent, which lives infinitely. You can have also some considerations linked to, we indebt the state now for future generation, but what we do now, although it's costly, we will reduce the harm coming from climate change, so future generation will be better off in terms of climate, and then we'll pay the cost on debt later. So here, again, the issue is not so much in terms of this overlapping generation or long-term issue. It's really during the transition. And during the transition, we say that, yeah, if public finances are not in order, we can get pressure coming from the market that could add an additional cost on the transition. So like shooting in our own foot. So keeping public finance in order is also critical for stabilization issue, but also for being in a good shape to tackle the transition. And the difference between Germany and Italy shows that. So with an initial low debt to GDP, you are better off and you can tackle this transition better.
Final question from the audience. Yeah.
Probably obvious, but also considering what public money needs to go into adaptation.
I mean, I'm just assuming it just makes the picture much worse, but have you looked at that or considered that? Because that's a big black hole right now, like how is adaptation going to be financed, even in the United States, you know, which is terrible debt situation, but relatively wealthy country. So would that be something that you would also look at, like as a next step, or is that be too difficult?
That's true. The literature has not done so far on the adaptation cost. That's an additional cost, pressure on governments. We haven't included adaptation cost here. But I mean, we work under the condition that we are successful in the transition. So we have so many charts, but we have the net zero by 2050. We managed to. So of course, there are still need for adaptation, despite this transition, the successful transition. But we can also think about adaptation more trade-off way, meaning that we are not fully decarbonizing the economy. We get the climate change impact and we adapt to this. So in that case, we could reduce the transition cost, but put more money in the adaptation cost. We haven't done that. We assume that we do the transition successfully and we neglect the adaptation cost that we will have to take into account anyway, which put additional pressure on government. But we haven't done that, but I would be ready to make the picture even worse.
Thank you. We're slightly over time. That's partly due to the fact that I outsource timekeeping to iPhone alarms. So apologies for breaking partly into your lunch break, but let's give the four presenters a final.